Katie Lynch, and I'm a postdoc, as Ken mentioned, here at the Annenberg Institute at Brown. And the paper that I'm going to present today is titled Instructional Improvement in STEM, a Meta-Analysis. And this is a project that I've been working on for the past several years with my colleague Heather Hill. And Heather and I set out to try to understand what characteristics of instructional improvement programs in STEM, and particularly we're talking about PD and curriculum programs, are associated with improvements in student learning. So I'll give the plan for this talk. I'll start with a background, some motivation for why we chose to undertake this particular study. I'll describe the how and the what, so the methods that we use to undertake this investigation. I'll share our findings with you, and then we'll have some time at the end for discussion. I'll start my timer to make sure that is true. Okay, great. And I should mention before I start, please feel free to interrupt me as I go with any questions that you might have, both questions of substance or questions of clarification, with the caveat that if you ask a question and it's something that I'm going to get to in a moment, I may ask you to just hold your question. So first, why were we interested in this topic? Why do we care about STEM instruction and improving teaching and learning in STEM? So first, we know that STEM instructional improvement is critically important. All of you are on the same page on this question, I think. So we know that, for example, on the most recent administration of the NAEP, only 34% of 8th graders scored proficient in math in the United States. We also know from observational studies of classroom teaching in the US that instruction tends to be limited in cognitive demand and limited in disciplinary concepts. And so there's clearly a lot of room for improvement in STEM teaching and learning in this country. And we also know that the STEM space, or more generally in K-12 education, has been alive with reform efforts in recent decades. So for example, there's charter schools, school accountability, teacher evaluation, but many of these types of initiatives do not provide specific instructional guidance to teachers. They don't tell teachers how to change their teaching in the classroom. And our hypothesis was that unless you change what is actually happening in the classroom, so those core processes of teaching and learning, the interaction between teachers, students, and content, you are unlikely to see improvements in student learning. And so Heather and I wanted to know when we look at programs that actually try to improve teaching, improve instruction in the classroom, what characteristics are associated with better student outcomes among those types of practices. School districts tend to use these PD and curriculum programs as primary policy levers for improving student learning. So we also know that these interventions are very expensive. So on average, districts spend between 1% and 6% of their budgets on teacher PD, and this is a conservative estimate. Some estimates are much higher. And the market for curriculum materials is estimated to be in the neighborhood of about $12 billion. So we want to know whether these investments are effective and also what makes them more effective.
If you put the 1% to 6% in dollars, what would you know what that would be?
That is a very good question. I do not, and that would be a good thing to put on the slide.
Yes.
Yeah. Yeah, good point. I'm just going to take notes for the next time when I give the talks, and thank you for all your suggestions. And we also know that teachers spend a lot of time in PD. So on average, teachers in the US, almost every teacher in the US spends at least 1 day per year in a teacher professional development. And we want to know that that time spent is valuable. So we looked to the literature to try to understand whether people had done this before and whether we already knew the answers to our questions. And what we found was that that was not the case. Recent reviews of the literature tended to include very few studies, primarily because in prior decades there were very few randomized or strong quasi-experimental designs examining these particular topics. So for example, one very heavily cited review contained only 9 studies, and that was across ELA, science, and math, that's a limited evidence base. But we thought that with new funding priorities that came into play around 2002, the early 2000s from IES and NSF, this fact would change. The number of STEM intervention studies would pick up that had these strong causal designs. And the reason is that these funding agencies started to prioritize researchers to conduct cluster randomized trials, so classroom-based RCTs. We looked at this new wave of studies that started to come out as a result of this funding, and what we found was that compared with these early studies, which tended to find positive impacts, the new wave of studies seemed to have a lot more mixed findings. We saw some null results, we saw some positive results, and we were interested in trying to see, can we identify some characteristics, a set of characteristics that explain some of this variability in the results that we're seeing. Hence this meta-analysis. So that led us to develop these two primary research questions. First, how effective are STEM PD and curriculum programs on average at improving student outcomes? And secondly, can we identify some specific characteristics of these programs that are related to better or worse student outcomes on average? So to structure this investigation, we conducted a meta-analysis. What is meta-analysis?
Is it okay for me to ask questions?
Please, yeah, go ahead.
So in the last one, the first question that you have makes it seem like you're going to be looking at like a representative sample of the STEM, PD, and curriculum programs. But really what you'll be looking at, yes, is the ones that had RCTs, and so are probably, it's not representative of the 1 to 6% of money spent on professional development.
I'm going to talk about this topic in detail. Yes,
Oh, okay.
that this is very important point.
So
Thank
sorry
you.
to just.
It's a little preview of my discussion.
Okay, good.
Thank you, Suzanne. That is exactly correct. How effective are programs of the type that were studied using these designs? Yeah. So how we structured our investigation was via a meta-analysis. Now, a meta-analysis is a type of research summary. There are many types of research summaries. Some are narrative reviews in which the researcher uses their professional judgment, which can be somewhat subjective, to compile a set of studies and describe the findings and kind of describe the evidence base. Meta-analysis is a type of systematic review, and a systematic review is a type of review that uses a systematic procedure which is set in advance for deciding which studies will contribute to the evidence base that I will review. And I'll talk about that procedure. Another way that meta-analysis, oh, go ahead.
Oh, sorry.
Oh, okay. Please feel free. Another way that meta-analysis is distinct is that we'll use statistical methods to pool results across the individual studies. And our goal there is to derive this overall pooled estimate of program impact, and also to try to examine moderators which might explain variability in findings. So this is an overview of the approach we use, and I'll talk about each step. First, we collected all qualified studies, and I'll talk about the specific criteria that we used through a set of systematic procedures. We included only randomized experiments and strong quasi-experimental designs, by which we mean essentially propensity score matching designs. We did not include studies in which teachers simply self-selected into treatment group and control group. We did not include post hoc matching studies or post hoc design studies where they did a treatment and then just sort of picked the control group after the fact. And so so studies had to, in order for a quasi-experimental study to be included, they had to explicitly match students on pre-test prior to the beginning of the intervention. As you'll see, that weeds out all quasi-experiments. Then we created this data set, and we coded the studies that we found for a set of characteristics, which I will describe. And then finally, we statistically modeled the impacts of study and program characteristics. So that's the overview. This Venn diagram depicts the inclusion criteria for a meta-analysis. So everything in the middle was included. In order to be included, the study had to examine the impact of a STEM PD or curriculum intervention for pre-K through 12 teachers. And we only searched for studies that were conducted after 1988. So this is mostly like the 90s through 2016 was our cutoff. That was when we conducted the search. It shows you how long it takes to conduct a study like this. It was required to have student outcome data. Specifically, we're looking at achievement test scores here, although we also collected information on affective things like engagement and motivation. But I won't be discussing that evidence here. We also needed the study to have sufficient statistical information to compute an effect size, and here we're using Hedges G. And then finally, as I mentioned, we had a set of methodological criteria, randomized or strong quasi experiment. We searched through these channels in order to find these particular studies. So first, we scanned the reference lists of prior review articles on these topics of STEM, PD, and curriculum. We constructed a set of keywords, and we searched these electronic databases, Academic Search Premier, eConLit, ProQuest, PsycInfo, etc. We also wanted to search the great literature because it's very important in meta-analysis to capture the universe of studies to the extent that you can retrieve them. And that includes searching through file drawers or other great literature sites that may disproportionately include null results or even negative impacts that tend not to get published. So to do that, we searched the websites of the RELs, Wellworks Clearinghouse, World Bank, Inter-American Development Bank, Empirical Education, Mathematica. These are some contract research firms that sometimes do these types of investigations. We searched conference abstracts, particularly we searched every SHRI conference abstract because SHRI is a conference that tends to have RCTs presented. And then lastly, we went on to the NSF, Cadre, and IES websites, and we downloaded lists of every PI who had ever received between 2002 and 2012 a grant from one of these agencies to conduct an intervention focused on PD or curriculum in STEM. And then we searched the internet to try to see if they had any conference papers or anything like that. We had our summer interns call them and email them. And many of them actually got back to us, sometimes with sad stories about their studies. But sometimes with reports that they had just not published for a variety of reasons.
In your earlier slide, you mentioned post-1998.
1988, yeah.
1988, yeah, post-88. So is that the 88 of the intervention or 88 of the publication?
Publication date.
Publication date.
Mm-hmm.
And then, so in this next slide, then I'm just drawn into this 2002 and 2012.
Yeah.
What about the other ones?
Oh, yes. So
Yeah.
earlier STEM grants.
Yeah.
So that's a good point. I think our decision to search only prior to 2002 was based on our thinking that this is when the funding guidelines changed
Okay.
to emphasize RCTs.
Okay.
Now, there's also somewhat of a practical component. I'm not sure if the earlier grants are online for this. They might well be, but at some point, I think our resources were limited to it. This was very time-consuming to
Yeah.
have someone go through every single grant that had been awarded in that decade. And I think we probably just weren't able to do
So
it
you
earlier.
didn't have much between 1988 to 2001,
Not at all.
right?
We do not have a lot of studies.
Oh,
And from that period, I think we have 10.
okay.
We have, I think, 85 studies that are from 2004 onward.
Okay.
And so we did some sensitivity analyses to try to understand whether the results differed between those early studies and the later studies. And I can talk about that. But we're heavily weighted toward new studies. So here's a Prisma diagram which just depicts what we found when we searched all those channels. We found about 8,000 records through database searching and another roughly 1,400 records through our other ways of searching. After we removed duplicates, we still had around 8,000 left. And then we had two raters read through every one of those abstracts for basic relevance.
Excuse me.
Wow.
Comprehensive. Did I mention it took us 3 years to do this?
Yeah.
So we excluded most of them because they were irrelevant. And then we advanced 656 articles to full text screening. And we had 2 graders read the full text of 656 studies, of which 561 were excluded, and we have the reasons for exclusions of those in the paper. In many cases, it's because you just couldn't tell from the abstract whether this thing would be relevant, and then once you read the article, you could tell that it wouldn't meet our criteria. Finally, from that large pool of potentially relevant studies, we came up with our final 95 studies that met all of our criteria. So this is a large number, but relative to the topic, it's not that large to think about that we can only identify like 95 studies of this topic in the past since 1989. Randomized experiments and quasi-experiments. Okay, so what did these studies look like? As I mentioned, we had 95 studies that we found, and the largest category of sources where these studies came from was peer-reviewed journals. But we also had 22 conference papers, we had 17 technical reports, and then we have a small smattering of government reports and dissertations. That's kind of what the sample looks like. And as you can see, if we had just searched for peer-reviewed journal articles, we would have missed a lot of the literature. So then we took those studies and coded them using a coding scheme. The first thing we wanted to understand was what type of intervention is this? Is it just a PD? Is it a just curriculum materials intervention, which in some cases the researchers simply provided curriculum materials to the teachers with no PD attached. So we have a few of those, and then we wanted to capture PD plus curriculum materials. And we were hypothesizing that perhaps PD is more effective when it's centered or focused specifically on a specific set of curriculum materials. We coded for the outcome type, so was this a standardized test versus a researcher-developed test? And our hypothesis there was that researcher-developed tests are likely to be more tightly aligned to the intervention, and therefore we were expecting we would see larger effect sizes. We coded each study for a separate set of codes, depending on whether the study we identified had a PD component or a curriculum component. And many of our studies had both, and so we applied both sets of codes to those studies. So these are the codes, this is an example of some of the codes that we coded for PD studies. So when we found a study that was about PD, we coded first for the timing and duration of the PD, how many contact hours, and what was the time span over which those hours were spread. We coded a set of characteristics related to the format of the PD. So for example, did teachers collaborate with other teachers from their same school at this PD? Were there ongoing meetings throughout the year where teachers would get together with one another and troubleshoot? Was that part of the PD? Was this thing conducted online, any part of it? Was there a summer workshop, coaching? And then who led the PD? Was it the researchers themselves or some kind of train-the-trainers model? We coded a set of characteristics related to what this PD was focused on. So we were interested in knowing whether the focus mattered, whether the focus was on kind of generic instructional strategies as opposed to curriculum materials. Was this thing focused on technology integration like calculators or smartboards, content-specific formative assessment, or was this focused on teachers' content knowledge or a focus on understanding of pedagogical content knowledges, or understanding of how students learn. And then last we coded for the activities, like what did teachers actually do when they showed up for this PD? And our examples here are things like, did they review generic student work? Did they watch a demonstration? Did they work through the curriculum materials themselves, solving problems as if they were a student? Did they sit in the PD and develop new lesson plans, or did they spend time reviewing their own student work? For curriculum materials, we had a separate set of codes. We coded for whether these materials included implementation guidance for teachers, which often takes the form of information about selected language or scripting that teachers could use, a set of instructions for teachers about how students think about this particular topic, and kind of examples of instructional moves that teachers would use. We coded for whether there was a lab component or a hands-on component to this new curriculum. Did it involve kids? Did it involve hands-on materials? We also coded for the intended dosage of the curriculum, like how much time were students theoretically supposed to spend doing this curriculum? And what proportion of the curriculum, the existing curriculum, was this thing supposed to replace? And we thought, some of these are like a 10-minute thing that's supposed to replace calendar math, and some of them, the new curriculum is supposed to completely replace the existing curriculum. So,
Next one.
yeah, please.
Did you do like age, or is it math, science, within science, different types of science? Am I
Yeah.
missing what age group or?
Oh, sorry, it was pre-K through 12, and yes, we coded for, like what grade were the kids in? And yeah, we coded for is this thing math versus science. This is not an exhaustive listing of the
Yeah.
codes, but yes, we
I just
definitely.
didn't know if you also restricted, but no.
Yeah, we have the whole range, and I'll talk about that in a minute. Any other questions about the coding? We can come back to it also. Okay, so a common problem that occurs in typical traditional meta-analysis, which is univariate meta-analysis, which many people may be familiar with, is that studies contribute more than one effect size to the meta-analysis, or they want to. So a study may have multiple effect sizes. And this can occur for a variety of reasons. For example, there could be a PD intervention, and at the end, researchers decide to administer to students a conceptual knowledge math test and also a procedural knowledge math test. Or it could be the case that we give students a test, a week after their teacher participated in a PD, and also we give them another test a year later. So univariate meta-analysis is not well positioned to deal with this very common scenario. The reason is that these effect sizes are dependent. And what researchers have typically done in those cases is either average those effect sizes together and come up with a single effect size per study, or they will pick one effect size from that study and include that in the meta-analysis. And they sometimes pick it at random, or they may pick it based on some pre-specified criterion like, let's pick the standardized test or the conceptual knowledge measure. And that results in a loss of information and also ignores those dependencies among the effect sizes that are nested within studies. So we argued in our paper that this robust variance estimation approach more properly modeled the structure of our data, where we had 95 studies, but we had 258 effect sizes. And what this method does is essentially adjust the standard errors to account for the dependencies between the effect sizes. And this is akin to, in OLS regression, adjusting for heteroscedasticity and standard errors, or clustering standard errors. And this accounts for correlated effects, like I mentioned, when, for example, you have multiple treatment contrasts with a common control group, or multiple effect size estimates, where the measures are correlated. The models that I will present, or for which I will present results, control when, depending on the model, control for whether this study was an RCT, whether the effect size control for covariance, the type of assessment that was used, an indicator for math versus science, and an indicator for whether this study was conducted at the preschool level. And the reason for that was that we hypothesized that preschool studies might have larger effect sizes simply because math and science are not as commonly taught in preschool, where there are universities taught in elementary school. And so sometimes, or our guess was that when researchers go in and implement a new science intervention, the control group has had nothing, and so the effect sizes can be huge at this level, just because of the nature of the comparison group. Okay, so I'll present the findings from this investigation. So first, as I mentioned, in our literature search, we found 95 studies, and within those studies, there were 258 effect sizes. So many of our studies are contributing multiple effect sizes to the analysis. We had 86 RCTs, and we had 9 quasi-experiments. And I will mention that these results that I will present are not sensitive to us just dropping the quasi-experiments and just using history, only the RCTs. So what did these studies look like? What did these interventions look like? We found that about 75% of studies included a PD and curriculum combined. And these numbers I'll just mention, just to orient you to the axis. Over here we have percentage of included studies, and then these are the percentage of included studies that included a treatment arm that was PD only, PD plus curriculum, or curriculum only. And some studies had multiple treatment arms. So for example, they wanted to test out whether the PD was effective by itself or the PD plus curriculum, so they're both included. So most of the studies in our data set have this combination. Not many studies had just curriculum alone. About 2/3 of our studies were focused on math as opposed to science. So 64% of our studies had math as their content area focus and 36% science. And we pool these together in our primary models, but the impacts are not different for math versus science. So the professional development programs that we found, this is to Susanna's point. Here's the description of the time span over which these PD were conducted, and also the average number of contact hours that we found for PD. So the percentage of studies for which PD was conducted over each time span, and the average number of PD contact hours, so the number of hours a teacher spent doing the PD in this sample of studies, is 45 hours. And the most common response for the time span over which the PD was conducted was between 4 months and 1 year. And to Susanna's point, or I will just extrapolate that this is to your point, yes. These are probably not typical types of PD that we see teachers participating in when they go to a one-shot intervention. We have about 15% of our studies in our sample administered a PD that lasted less than a week. But we also have 16% of studies where teachers are participating in this PD for more than a year. So that points to the fact that these interventions that tend to get studied are more intensive than probably what a typical teacher participates in at their school PD. Yeah, go ahead.
What's the distribution of the contact hours look like? Is it right tail skewed?
So the distribution of contact hours, we do have this in the paper, and we have the histogram in the paper, and I don't remember off the top of my head.
Not a big point, I'm just curious.
Yeah. And this will come up again about whether this is a normal distribution or not, because we try to look at the relationship between like how many hours you spend and student outcomes, and we try to model it in many different ways, searching for some pattern. Little preview there. Okay. What types of activities teachers were doing in these PDs that were included in our data set? So the most frequent activity that we saw was, we call this solve problems on this graph, but what this code was about is solving problems and working through the curriculum materials. That was the most frequent activity that we see. In about 35% of studies, we saw teachers just observing a demonstration. About 20% teachers were developing their own curricula, lesson plans, and then reviewing student work, whether generic student work like samples of student math problems or thinking about students writing in science, whether it was generic or whether there was their own, was a kind of less commonly observed activity. For curriculum materials, the intended dosage of the curriculum materials on average was about 67 hours. And we estimated that that was about 4.5 months of instructional time at like 45 minutes a day, I think we assumed for that conversion. And the characteristics of these materials, oh yes, about the curriculum was intended to replace on average about 90% of the content. So we did not observe a lot of those calendar math interventions that I was mentioning before. These are mostly like intended to replace the curriculum that was existing. And the percentage that had implementation guidance or scripting and language around the new curriculum was about 43, and about 28% of cases that these were like hands-on curriculum with kids.
And this is
new materials.
replacing the curriculum of the whole year? So they were replacing
No.
90% of the whole year's?
No. This was like of a typical lesson.
Oh.
So I should have specified that. Like of a typical lesson, what proportion was this thing supposed to replace? So, because like I said, sometimes people try to do interventions where it's like, let's just replace 15 minutes of your math class with this new comparison approach.
Of the lessons that it addressed, it replaced all. It's of like 90%.
Yes. Right, exactly. So I'll orient you to my presentation of the results. In order to describe kind of the overall average impact of these STEM instructional programs, I'll talk about 4 kind of key categories, or I'll highlight these 4 key categories. One is whether impacts varied by the type of assessment that was used, whether impacts varied by the type of program that was being used, the focus of the program, and the format. So first, just to orient you to this graph, and what we have done here is taken the regression-adjusted mean effect sizes for each treatment type and then converted these effect sizes into percentile rankings for ease of interpretation. For those who prefer Hedges G, I have also included Hedges G below. So this is like the percentile ranking. Let's look over here. This axis shows average program impact on student achievement in percentile ranks. And on average, what we found was that students who participated in one of these, students whose teachers participated in a PD or who had new curriculum materials scored at the 58th percentile relative to a typical comparison group student who scored at the 50th percentile. So the typical treatment group student scored about 8 percentile ranks higher than the typical control group student. And that corresponded to an average pooled Hedges G effect size of 0.21 standard deviations. So on the right-hand side of the graph, I have broken this out by the type of assessment that was used. And we're trying to understand whether impacts would differ depending on whether the assessment that was used was something that the researchers developed as opposed to a standardized test, which tend to be more distal. And what we found was that the impacts were quite different when the test was developed by the researcher. So as you can see here, when kids took a researcher-developed test, they tended to perform about 14 percentile ranks higher than a typical student in the control group on that test. But when we look at state standardized tests or other standardized tests, we see that the differences are smaller. However, the kids who took state standardized tests still tended to perform better on those tests than kids in the comparison.
Would the 64 and the 58 have 3 stars on it too?
That.
Yeah,
So
so
sorry.
Yeah, are your stars about significance?
yeah, so these stars are comparing the kids who are comparing scores on the standardized tests to the researcher-developed test. That's the contrast.
Okay.
I also found that a little confusing at first. That's the comparison. And yes, this should have stars on it really because I'm comparing the treatment group to the invisible control group who is down here at the 50th percentile. Thank you. So on this slide, I am presenting results for program type. So these are the impacts of these programs on student achievement by whether this program was PD only or curriculum only versus both combined together. And what we see is that on average, when PD and curriculum were offered together, the impacts were larger. So a typical student in the treatment group whose teacher participated in PD and curriculum combined intervention would score about 10 percentile ranks higher than a typical student in the control group. And for PD only or curriculum only, which we pulled together because they were both small, the difference was 6 percentile ranks. And here again, the stars are contrasting this category versus this category. But both of these would be significantly different from the control group. So here I have the impacts of these programs on student achievement by the focus of the program. And the this is again for interventions that involve a teacher professional development. And over here we see that among the different foci that we examined, in only two cases was the focus associated with stronger student outcomes. So when teacher professional development was focused specifically on how to use curriculum materials, we saw that students in those interventions scored significantly higher than the average impact. And when the teacher professional development was focused on improving teachers' content knowledge, pedagogical content knowledge, or understanding of how students learn, those students also performed higher than the average of these treatments.
What were the p-values on the other? They are bigger point estimates.
Yeah, they're just, oh, that's a good, I have it in the paper, but yeah, they're just fewer studies with those. And lastly, we looked at differences by the format of the PD. So here we have the achievement of typical students in classrooms that receive the PD or the curriculum material that actually receive the PD, depending on the specific format. And what we found was that the formats that were related to student outcomes among this set of formats that we examined were teachers participating with other teachers in the same school, teachers participating in these ongoing implementation meetings. So throughout the PD, this was when teachers had the opportunity to collaborate in troubleshooting meetings that were ongoing kind of throughout the time span of the PD. And surprisingly, participating in the summer workshop was also associated with stronger student outcomes. The much maligned summer workshop was associated with better student outcomes on average in this study. We also found that interventions that included any online PD, so any component of the PD was conducted online, had worse impacts on average. That doesn't mean that teachers going to an online PD experienced some negative outcomes. It's not that students performed worse, it's just that they performed worse than the treatment group average. There were also a number of characteristics where we did not observe any differences. First, we did not find any relationship between the contact hours of the professional development and the size of student impact estimates. And we were somewhat surprised because conventional wisdom, you might expect the more time you spend in the PD, the better student outcomes will be. And we attempted to model this in a lot of different ways because we thought maybe there's some threshold after which teachers are so frustrated with the PD, like for a while, more is better, but then there's some kind of drop off, and we didn't observe any such relationships. It seemed that there was no connection between number of contact hours and student outcomes. And so what we concluded from that was that perhaps just the content of the PD is more important than the amount of time we spend doing it. We also did not find relationships between any of the PD activities that we coded and student outcomes. There were no significant relationships there, so we didn't observe anything in that category.
Can I have clarification?
Yeah, go ahead.
So maybe you said this before I came in, but on the contact hours,
Mm-hmm.
the PD contact, that's contact with what?
Time they spent in the PD. And we define that as like any PD activities. So we would include time that they spent, anything that was reported in the study as time they spent on the PD. So if the PD was like a summer workshop that lasted a week, and then throughout the whole year, they had an hour a week of coaching, and they also met with their fellow teachers for an hour, we included all of that in our estimate.
Wow, so that's kind of hard to wrap one's head around that doesn't matter. Right?
Yeah.
What I should do is just shove out some material and walk away.
Well, it's counterintuitive. It's also not an uncommon finding in this literature. So the other example that I can think of is Mary Kennedy, who did a nice synthesis. It's not a meta-analysis, but she sort of synthesized this literature and came up with the same conclusion sort of qualitatively by looking across studies. And so I think her conclusion was similar in the sense that first she thought that perhaps, we thought, and actually I shouldn't attribute this thought to her. Her conclusion was just like content matters more than contact hours. We tried to dive a little deeper and we were like, okay, there has to be a relationship. So maybe it's these high contact hours studies, there's something special about them. Like maybe they were also mandatory. Maybe that was in like LA or this one science, some districts mandated everyone to go to PD for some really high amount of time. So we went back and reviewed the studies that had like kind of high number of contact hours, really low number of contact hours, trying to understand whether we could kind of even qualitatively come up with some reason for this lack of a relationship, but we couldn't discern any clear pattern that we felt.
What is the low end of contact hours for this group of studies?
I don't actually have that, do I?
Yeah,
I don't
I
have
don't
that
think
broken
you
out,
do.
I only have less than a week. It's not that low.
That's what I was wondering.
Yeah,
Is it- you
it's
might-
not like an hour.
Yeah,
I should include that next time I give this, a histogram of that.
just because it is a really counterintuitive result, but if it's, if it's pretty high anyway at the bottom end, you could imagine why that might be true. The other is just
Yeah.
like, because I've been thinking a fair amount about adult behavior change. Do you have any kind of measures of whether there is, even things like follow-up and, later observations or reasons that people would feel like they would have to implement things in any of these?
Yeah, so that's, let's see. Reasons why they would feel like they have to implement it.
Like, do
So
people
like
think-
the implementation meeting, those are like
Does someone
ongoing.
come and observe them in their classroom? Or do they?
Oh, yeah, we do have that, expert coaching, that is one. So there's some social accountability here
Yeah, like,
that,
I guess social accountability is what we're looking at.
yeah, like this pattern of findings could be consistent with a social accountability story in the sense that like, on average, interventions where teachers participated with other teachers from their school were more effective. And that could be that they're in a community and they're sharing ideas with each other. And the ongoing implementation meetings is, I think, touches on what you're referring to, because that is a measure of, did we continue to meet throughout this process with a group to troubleshoot? And probably just check in about progress. Yes.
And I have one other question.
Yes, please.
Oh, Did you do anything controlling for other aspects of it? So it's hard for me to think about how these things could be correlated.
So controlling for things.
So, there's not that many programs and they each have so many characteristics, so you can't throw it all in, but, maybe the ones with more contact hours were the ones that were bad on these other things, or maybe they were with different age group. Like what kinds of controls do you have?
Yeah, so we did a ton of this in
I'm
our
not
descriptive.
surprised. Yeah.
Yes, because we, our of course first tendency was to think like these patterns can't be real. Like let's just try to break it out. Like maybe only the preschool studies are the ones where
Exactly.
this particular like the online PD was happening or something like that. So in our models, we have a set of controls for the things that ended up being correlated with any of the outcomes. I actually thought I had that listed in here. But anyway, yeah, so what we did, what we ended up doing in the paper is that first we, for each, we have a set of five sets of meta-regression models, and that's what's in the paper. So in each of those tables, first we model the impact of each item separately, and then we have a joint measure at the end. And so that's where you can see like how the R squared changes when you go across models. Next question, or should I continue?
I have a question about the contact hours
Oh yeah,
on the bar graph.
this is,
On the-
everyone wants to know more about this, so this is helpful. Okay,
On the left, all the way at the left, there is less than 1 week or
Yeah.
less than 1 day, all the way to the right.
less than 1 week, yeah.
There's more than 1
More
year.
than a
So
year.
how does this align with the number of hours? So could it be there's only 7 meetings in a year and that they still fall in the 16 category?
Yeah, definitely. It's not a one-to-one mapping. It's certainly like this, the thing that I just kind of chose to put on this graph is the time span.
So it's the start date of the PD and the end date.
Exactly. Yep, exactly. So this more than 1 year could easily, it was just the total time span, start date to end date, that's it. It could be that this was really heavily front-ended. In many cases, the more than 1 year, it's a design where they have a summer workshop and then something over the year like coaching. And then they have another summer workshop and then they have some more coaching or something in the second year, sometimes a lower dose. So, but that's a great question, it's how those two things can be related.
So what I'm hearing seems to be somewhat related to Susanna's question is that the number of professional development contact hours, the quantity doesn't really matter that much, right? There's not much of an effect variation. But it is the type of work that is involved that counts more. And that backs the question, which is related to Susanna's question, that is, the reason why coaching matters more, that particular activity matters more, is because it really targeted on a particular challenge in that particular set of schools or that group of teachers, right? So that kind of raises the question, is the kind of the ecological context or whatever terms that you want to use, right? That is how can we connect your findings to that?
Okay. May I run through my final slide
Okay.
briefly, and then just because this is a critical point. So this is the okay. Here's where I summarize. Okay, so in what ways do these findings sort of confirm or disconfirm conventional wisdom? I think we've talked a bit about this intuitive sense that we have that more contact hours would be related to student outcomes, and we just don't find evidence of that here. We did find evidence of that studying curriculum materials, collaborating with other teachers, and focusing the PD on improving teachers' content knowledge, pedagogical content knowledge, and understanding of how students learn, those characteristics were associated with improved student outcomes, and that is similar and aligned to kind of conventional wisdom in this area. So what we found is that in our data set, we saw these average positive impacts on student achievement, And I want to note several limitations to this analysis that point toward potentially productive areas for more research. First is what I'll call the boutique problem, where only special, especially high quality interventions tend to get studied. And it may be the case that in this data set, the types of interventions that we're seeing that tend to get an RCT done on them, for lack of a better term, are different systematically than the types of PD that teachers typically get in classrooms. Another limitation here is missing data. Many study reports, we tried to code for many characteristics that we just didn't have information on, and we need more information on, for example, typical types of PD that teachers might be receiving. And then lastly, the district context. As part of our original logic model, we had a set of district contexts that we wanted to code for. For example, features of the district context that we thought were going to influence the effectiveness of this intervention, curriculum and PD. For example, what is the district and school leadership support? Do we see evidence of that in this intervention? Are there competing priorities in this district? Are they trying to focus on ELA and putting that into the intervention? Do we have any evidence of that? What is the level of financial resources that are being put into this intervention? We found almost no information on the district context in these study reports, and it's critical that future studies and empirical studies in this area include more information about this context so that when districts and researchers look at this, they can try to understand how this may translate into my context or a different context that I'm interested in. So those are important steps for future empirical studies. This detailed reporting on the district, future studies on typical practices that are occurring on the ground, and also, lastly, future studies that experimentally manipulate these variables so that we can understand the relationship with student outcomes. So to John and Susanna's point, this is a, meta-analysis is inherently descriptive. If we can randomly manipulate just the amount of time teachers spend in the PD, we'll have a clearer answer for what this relationship is. So the conclusion here is that the evidence base is much thicker than it was even 10, 15 years ago when people tried to look at this field. We were able to find 86 RCTs and some quasi-experiments that are pretty strong in this area. So we have a lot more knowledge of how STEM, teacher, PD, and curriculum work. We also found that it was useful to take these two and study them together because we thought that PD that focuses on curriculum may be more effective on average, and we did find that to be the case. And we found that, going back to my original question about changing the processes in classrooms, we found that providing teachers with these certain types of learning and collaboration opportunities was associated with improved student outcomes in our data. So these opportunities to learn about the materials they would use, to practice, to improve their content knowledge, and to meet and collaborate with other teachers. And we think these types of experiences are probably uncommon in typical district practice, but potentially useful and effective. The whole paper with 130 pages of appendices is available for your viewing pleasure on Annenberg, and it's in press at EPO, which is Educational Evaluation and Policy Analysis.